Fifth graders, today is Wednesday, January 15th, and we are continuing right along with Module 3, Lesson 10. And today, our learning goal says that we are going to practice and work on adding fractions where the sum, the final answer, is going to be greater than 2. That tells you right off the bat, you are working with fractions that are greater than 1, right? Because if you have something smaller than 1, and you add it to something smaller than 1, will the sum be greater than 2? So today, really, the theme of today is don't forget the whole number, because we know that there's going to be whole numbers involved. That's the only way we can get greater than 2. But to do something greater than 1 plus something greater than 1 in order to get something greater than 2. If something is greater than 1, will there be a whole number component? Yes. So today's motto, and for the rest of your life, is don't forget the whole number. Good. So whenever we have a whole number part and a fraction part, we call it a mixed number. Okay, so here we have a mixed number, 2 1/5, plus a mixed number, 1 1/2. Now, how could I use the commutative property? Whenever I'm adding or multiplying, I like it because I can use the commutative property. I can think of this as 2 plus 1/5 plus 1 plus 1/2. And then what I could do is I could commute all the whole numbers to one side and all the fractions to the end. I could say that this is equal to 2 plus 1 plus 1/5 plus 1/2. And I like that because I know already 2 plus 1 is 3. So I can say that this is 3. Sorry, let me move my number line down a little bit. Okay, I can say that this is 3 plus 1/5 plus 1/2, right? Okay, so on my number line then, I could say 0, 3. That's my first part, right? Then I have to plus 1/5, and then I have to plus 1/2, right? So this is plus 3, plus 1/5, plus 1/2. Now, could I do that already? No, because I don't have like units. I need to find the greatest common denominator for 5 and 2. What's going to be the greatest common denominator? Everyone? 10. So I can say that 1/5 is equal to, least common denominator is 10. 1/5 is equal to how many tenths?
2 tenths.
Good. And 1/2 is equal to?
5 tenths.
So here, instead of adding 1/5, I could say that I'm adding 2 tenths. And then over here, instead of adding 1/2, I could say I'm adding 5 tenths. So if I'm at 3, this is 4 over here, what am I at right now? 3 and?
7.
Good. So the answer is 3 and 7 tenths. Good. Okay, my answer would be right here, 3 and 7 tenths. So again, once we commute all the fractions to the end, we can see that we need to make like units. What is my least common denominator going to be again?
10.
Okay, so I can say that 4/5 is equal to how many tenths?
8 tenths.
What version of 1 are we multiplying 4/5 by in order to get to 8 tenths? What version of 1, Sushant? 2 over 2, very good. And then we still have 1/2, which was just like before, equal to 5 tenths. What version of 1 are we multiplying 1/2 by to get 5 tenths? Maria?
5 over 5.
5/5, very good. So we can rewrite this problem as 3 plus 8 tenths plus 5 tenths. Now, I'm going to show you on the number line. My number line is not drawn to scale because my 0 to 3 part is very small. As long as I label that, though, that's okay. Okay? Now, here's 4, and here's 5, my whole numbers. If I have tenths, I need to divide it up into tenths. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now to 3, I have to add 8 tenths. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. After I add the 8 tenths, what number am I at? What's the value of this part right here? 3 and?
8 tenths.
Good. So over here I added 8 tenths. Right? What else do I have to add? Am I done?
No.
I have to add 5 more tenths, right? Watch. 1, 2, 3, 4, 5. I ended up here. Did I pass another whole number? Yeah. So what is my whole number going to be?
4.
4, and then my final answer is here. So it's 4 and
3 tenths.
3 tenths. We can see that when we use the number line. But what would happen if I just used numbers? It would be 3 and, what is this?
13.
Yeah, I would have 3 and 13 tenths. What do we know about 13 tenths? It's more than 10 tenths, right? So this is the same as 3 and 10 tenths plus 3 tenths. But we can regroup this 10 tenths to become one more whole number. So that's how you use numbers to show that it's 4 and 3 tenths. Before we even solve it, I want to know what two whole numbers will this answer be between. I'm going to tell you right now that this needs to be equal. It's going to equal a whole number, right? Can you guys see why? Let's add the whole number parts first. What's 2 plus 5?
7.
So could this sum be less than 7? It's going to be bigger than 7, right? So the lower end we know is going to be 7. That's our lower whole number. Let's look at our fraction parts. We have 2 fifths plus 3 fifths, which is 5 fifths. What do we know about that? It's 1. So really the answer to this is 7 plus 1, or 7 plus 1, which is?
8.
So we can't really say in this case that it's going to be the sum will be less than 8. It's actually going to be equal to 8. Do you guys see that? But try this to PE. What two whole numbers will this answer be in between? And then we'll solve it for real, okay? So let's see, what would be the lower end of things? What's 3 plus 4?
7.
Is there any way for this to be less than 7?
No.
So we know that the lower end is 7. Do you think the higher end, it'll be more than 8, or do you think it'll be more than 9?
More than 8.
Do you think it'll be lower than 8 or higher than 8? Let's see.
Higher than 8.
How do you know that it will be more than 8? Because we have 1/2 there. What would I have to add to 1/2 to make it exactly equal to 1?
1/2.
What do we know about 7/8? It's more than 1/2. So is this answer going to be less than 8?
No.
No, it's going to be less than?
9.
Good. So we know that it's going to be more than 8. So our lower end of things can't be 7. It's going to be 8. We know that it's going to be more than 8. So when you see these problems, it's asking you to figure out what two whole numbers the sum will be in between. And then let's solve it for real. So again, we have 3.5 plus 4 and 7/8. Let's use the commutative property. This is equal to 3 plus 4 plus 1/2 plus 7/8. We know that 3 plus 4 is 7, so it's going to be 7 plus 1/2 plus 7/8. Now, do we have like units? We have halves and eighths. What's the least common denominator? Is it 2 times 8 equals 16?
No.
What is it, you guys?
8.
Good. 1/2 equals how many eighths?
4 8.
So I can rewrite this as 7 plus 4/8 plus 7/8. How many eighths is that?
11 8.
7 and 11/8. What do we know about 11/8? Yeah. So really this is 7 plus 8/8 plus 3/8. But 7 plus 8/8 is?
8.
So the answer is 8, and
3 8.
let's check to see if our inequalities were correct. Is it in between 8 and 9?
Yeah.
Very good. Okay, do you understand what this kind of problem is asking you to do? Very good.